Hi, this is Jacob Roden for the follow-up on the prismatic machining workbench in CATIA 3DExperience. So here we have another part that I just designed real quick that we'll be drilling these holes through. So this is a 3x3x3 cube with a couple half-inch holes through it in just a 3x3 grid. So obviously, just once again, we already have our safety plane put in there, half-inch above the part, and then we have all of our holes and everything and all of our sketches set up. So then what we're going to do, just like last time, we're going to go into prismatic machining and just going to have to go through the same steps. So we're going to build another generic machine because we have not built our own yet, and then rough stock. So here obviously if we go in, we can see that I actually have not put a rough stock in. So compared to last time where I already had that rough stock, we can build one. So we're going to select rough stock. We're going to do existing 3D shape, not a new 3D part. And we're going to select, it's going to be rectangular stock, because obviously this is rectangular. And select 3D shape, and we're just going to click on this part body. If you want to create geometry, yes. There we go. And you can see this yellow bit is where, because obviously it's stock, it's yet to be drilled, it's actually going to be filled into this whole 3x3x3 area. We're going to press OK, and that'll create our rough stock. Now what we want to do, because as you can see when we're trying to select those holes, it's selecting that rough stock. We're going to want to hide that rough stock, just to make sure that when we go to select our holes or maybe select our faces, we're not accidentally selecting the face of a rough stock when we wouldn't want to. That's especially dangerous if you're trying to select things like how far your hole is going through, or clearance planes when maybe your stock is obviously not where you want to be clearing. Then we're going to go into our edit part operation, and then maybe we can say that this is actually stainless steel, and we can see how that might affect our feeds and speeds a little bit. And we're still obviously doing drilling, and the quality is still going to be roughing because we're not too worried about the finish for these, I guess. So we're obviously going to select our design part, press on its part body right here, double click. Don't have any fixtures once again. Gonna select our rough stock. Okay, so rough stock, double click, and then our safety plane. Sweet. And then that's all good. And you can also, if you need to, there's more settings over there. And then tool and assembly search, resource creation. So obviously last time we had a much thinner part with a smaller hole, but this time when we do our creation for tools, we're going to have to select a new type of drill. We're going to have to make a new type of drill. So obviously, if we try to drill with this is about 2-inch long drill. 2 inches is not going to drill all the way through 3 inches. So you're going to smash up on this, you're probably going to break your tool, probably going to ruin your part, scrap it. So what we're going to want to do is we're going to want to make sure that this is long enough. Now if we set this to 3 inches, you would think, okay, so now we have a 3-inch tool that can go through a 3-inch part. But you'd be incorrect, because this can only go up to this face right here. And as we can see, the tip is going to reach that 3 inches. So that's not going to fully go all the way through and clear that hole up. So we'll add a little bit extra, we'll make this 3.2, and then you can see, okay, so this will go all the way through the part itself and have enough room to clear that hole off. So now what we're going to do, and you can also see right here with this length, obviously we have enough to where that face will clear it out and everything. So now we got that at 3.2. We're going to make this about a 4 so we get some angle, and the overall will make it about a 5. And that looks like it should, and obviously we want to make sure, excuse me, this is the right size. So we're going to make this 1/2 inch for a 1/2-inch diameter, and that is what we want. And we can also make this maybe a little bit bigger, a little bit beefier. Sweet. Now once you have your tool to be the right size, you can rename it if you need to, but we'll just save it. Shows up right there. Don't need to get any other drills or anything ready, but obviously spot drill, center drill, countersink, multi-diameter, counter bore mill, reamer, boring bar, boring and chamfering, 2-side chamfering, thread mill, and then styluses, stuff for lathes, different inserts, different tool holders, all this kind of stuff that you can get really, really detailed on when making your tool library. And then even above the drilling stuff, we have the different kinds of end mills and side mills. So maybe if you're making a tapped hole, you'd have your spot drill for doing your first little initial hole. So then your drill's not going to wander. Then you drill through it. Then you take your countersink tool and countersink the top of that. And then you take your that's a thread. Where's thread? Probably just side. Then you can take your thread tool and run it through to make sure that your threads are of the kind of right quantity and right percentages that you need. But then obviously we have our one tool that we're going to need for now. Close that out. And then we're not going to do any of these automatic features yet. And then programming. And then axial machining. And then instead of selecting from up here, you can also just select it down here. And obviously here you can see that we have drilling, spot drilling, boring, axial finishing, T-slotting, tapping, thread milling, circular milling, and sequential drilling. So all these different features. And if you go in prismatic machining, we have things like roughing and contouring and all this stuff for actually milling out different shapes. And then just more like doing head changes and tool changes and machining processes, automation, analysis, all these kind of other little workbenches and tools that we have. But I guess I kind of run through them quickly. Obviously drilling is going to put a hole. There's a couple types of drilling. So drilling with a dwell delay, so letting the drill sit for a second to probably clear up the bottom of that hole. Drilling to break chips, so peck drilling, so that you make sure that you get those chips cleared out. Because if you just drill straight through and the chip loads too much, you can actually end up getting your drill stuck or breaking it in the part, and then you probably have to scrap the part. And then deep hole drilling, which is just another process. And then spot drilling, which does a little initial spot in the part, so that then when you have a drill, especially if you're going through a deeper hole, it's good so that it won't let it wander on the surface, so you can get a more precise placement of that hole. Boring, so we have boring or boring spindle, stopper back boring. So these are all different ways to make sure that you, once you've drilled a hole, you can take a boring bar or a boring head and have it go around the inside of that hole to bring it to a very, very tight tolerance. So you can bring that within 1,000ths, you can bring that within half a thousandths, just depending on your boring bar. So if you have like a really tight tolerance for a shaft that you need to put through a hole, you probably want to bore that hole out first. And then we have axial finishing, so we have boring and chamfering, counter boring, counter sinking, chamfering two sides, or reaming. And these are all different ways of just doing finishing. So if you want to put a chamfer up here, or if you want to ream out a hole, so maybe you have another kind of tight tolerance, you could put a reamer through this and bring it a little bit closer without going through the kind of work and effort of boring, and get a little bit of a smoother finish than boring can give you. And then we have T-slotting. T-slots are good for work holding. So the tables of most machines will have T-slots already milled into them. But depending on, maybe you're making another table for little tools and things to affix to, you can use a T-slot tool. It's kind of like a end mill in a way. It's just a specially shaped end mill that will come in and put those T-slots in. And then we have tapping, tapping or reverse threading, or thread without tap head, which all involve putting threads, so you could maybe screw a bolt into a part. Then we have thread milling, which is good for harder materials like stainless, where it's a end mill with a certain kind of thread pitch and diameter on it that you can actually put it into the hole. And instead of running like a drill where it runs down through and circles down into the hole, this will actually fully move itself around the edges of the hole. It's also good if you have a large diameter thread. And this will take that thread mill and run it around the inside of that hole, just milling those threads into it. And then here we also have circular milling, which would be making a hole but just using an end mill instead. So maybe if you have a hole with a bigger tolerance and you don't want to go through the process of having to pull out another drill, because you can just really quickly bring it in. And then sequential drilling or sequential groove operation. And those are pretty much the drilling options we have in here. And then obviously in prismatic machining we have pockets and 4-axis pocketing and facing, profile contouring, roughing, plunge milling. So all those kind of more specific, making kind of more specialized parts. Then we also have, you know, helix following and groove milling, all these much more fancy, and starting to get into 4 and 5 axis milling almost. But obviously for this example, we're just going to go to axial machining and just do drilling. And it's obviously up here you have the different types of drilling if you want to pick. So you kind of have this one, and then you get your little subsection of what kind of drilling. So, you know, we could do, you know, deep hole drilling if you're doing something really crazy, and we had some really long tools that we need to do. And then we'll select our tool. Obviously in here we could search for the actual tool that we have if we had a big library, but we'll just select our tool right here. Don't want to keep searching because we've already picked our tool, and then select the hole. And then in the last time we physically went into the part body and we selected the holes, but if we wanted to select all of them, obviously this will select these as a group. This is just our initial, so we can select our initial one, and then we can also select the entire group of them as one, and that'll grab all 9 of them for us, and it'll even automatically say the way that the drill should move through them. And you see the check marks up here, so we'll double click, so we've selected those, and then grab hole tops. It's going to be that top surface, and then we'll double click. Hole bottom is going to be that bottom surface. And this is what I was talking about when I was saying, with if you don't hide this rough stock, you'll be selecting the rough stock bottom and the rough stock top, which could be an issue depending on if you're doing finishing passes on the top and bottom maybe. And our check plane, which is going to be our safety plane, you also just press this little check mark instead of having to double click. And then obviously these are going to be through holes once again. Go into our strategy from tool assembly. Approach clearance, we're going to give 1/4 of an inch again. Breakthrough, we're going to give 1/8 of an inch again. And then first compensation, output point. And then we have our macros once again we're going to put in. So our approach is going to be the same. Going to select that clearance plane. Same with our retract. Axial motion up to a plane. Select the plane in the diagram. And select our safety plane. Clearance automatically has it to safety plane. Linking retract, we're also going to have to put in, as we are with linking approach. You can select that. And then obviously you can copy these and save them, and then you could, you know, instead of having to just automatically or manually put them in, you could just go, oh, gotta put it in the safety plane, let me put in my macro for that. Or if you have obviously more complicated movement, you put it in. We have our feeds and our spindle output, which I believe this is different than what we had last time. For the kind of speed you have, if it's not, then you could manually just calculate with your materials and the proper tables, I think, which are all in, I mean, something like the machiner's handbook, or you could just use a machining calculator to find, based on the material, what speed and feed you would need to make sure that you're drilling that hole with proper chip clearance. And then obviously we have our programming, so that's everything selected, so we should be able to just press simulate, and we can see there's no red. Tool's moving up above that clearance plane, so it's not going to be hitting anything. Obviously if you had like a toe clamp that was in this clearance plane, you'd want to move that clearance plane up so that it would clear the toe clamp between each movement. But you can see it's going to come down and then drop down a little bit and then drill, and then come back up and then move over one, come down and drill, and keep repeating that. And then in here we can press this as well to turn our speed down a little bit, so when we watch it we can see it a little bit better. We can watch that come through and drill all those holes. And yeah, and then obviously once again you can do seeing if your stock's going to clash, seeing if your machine's going to clash, just based on the part and the movement of everything. And you got your toolpath information, time. So this one's obviously taking longer because we're doing more holes than last time. It's going to take 2 minutes. Obviously you could go in and change the speeds and feeds and the rapid rates to just make that fly by. But yeah, and that's pretty much, once again, how you do the whole drilling thing, all the different drilling options. And another thing with drill options, like the actual tooling options, you could get, you know, instead of maybe using something like a high-speed steel, you could get a carbide with through coolant, which would let you lower this time a lot more. And there are many, many different options with tooling and all the different companies that might be able to take you to getting that time down, because that's obviously where a lot of the machining money is time. But thank you. I hope you learned a little bit and enjoyed watching, and have a great day.